Welcome to my presentation on social objective functions and social indicators in optimization models for sustainable supply network design. And by that title, you can see that I am not an SLCA practitioner or researcher by design, but someone who aims at integrating socially sustainable decision-making into another discipline. And this is strategic supply chain network design, which I will talk a little bit at the beginning of this presentation. Then I will talk about the state of the art of socially sustainable decision making in that field. And lastly, I will talk about our own attempts of raising that combination of disciplines to a new methodological level. To briefly set the stage, strategic network design problems are problems on a strategic and generic level, and they are also often greenfield problems. That means you have some sort of discrete spatial resolution that can be distinct cities or even street corners, or like in our case, European countries and their regions. In these regions, you may have different amounts of sourceable raw material, and you have in other regions different amounts of demand for your product. And then you need to take decisions, for example, on the location and capacities, and maybe, for example, also the technology of your facilities. In our case, that would be biorefineries that produce second-generation bioethanol from agricultural residues. You need to take decisions on the type and amount of raw material that you source, on the transport mode and the transport amount between different regions and different facilities, and then finally on the distribution of your product to the different demand regions. And all of these decisions can be attributed with different economic and environmental impacts. For example, the revenue from selling your product, or the cost of setting up a facility, or in environmental terms, all the manifold environmental impacts along the entire supply chain, which can be, for example, retrieved by life cycle impact assessment. And then you can, in modeling terms, you can display your decisions as variables and the different economic environmental impacts as parameters, and then these kind of models are then often solved as by mixed integer linear programming, which is a technique for the optimization of variables in a linear objective function, subject to linear inequality constraints. And these objective functions could, for example, be to maximize the profit, to minimize certain environmental impacts, such as greenhouse gas emissions, and so on. And both this methodology, as well as solving economic and environmental objective functions, is well established in the field and is state of the art. However, for the social dimension, things get a little bit more intricate, because the design of the supply network is on a generic level. That means it's not focused on a single existing facility that could be assessed in terms of their social impacts and sustainability, and it's on a strategic level. That means it's not, at least not primarily, product focused or focused on the actual origins of the very raw material that could be used. And thus, the dimension is rarely adequately addressed in literature, as we will see. Ultimately, our goal is to integrate the social dimension adequately into this kind of decision problem and optimization model, which is point 3 on this agenda. But before that, we conducted a review on 91 articles in the field of strategic network design that have not only economic and environmental, but also a social objective function. And we looked into how the social dimension, how social indicators are integrated here. In the review, we looked into different aspects of the studies. For example, the industry sector that a study is set in, or whether the study cites frameworks for social assessment and how that affects the number and kind of social indicators employed. But at the core of our review, we looked into the very social objective functions. And a typical social objective function may look like this. We have in the first row the number of jobs that is created by the decision variable on a facility location times regional unemployment rate, and then the whole term is given a weight. The second term is the economic value that is created by setting up a facility times the regional development level. And this term is also given a weight. And the third term is the number of days that is lost by establishing facility locations with a certain facility technology. By analyzing each social objective function term by term, we can draw the connections between the decision variables that appear in the models and the social indicators, or I should say the kinds of social indicators that these decisions are measured with. For example, in 62 out of the around 90 articles that we analyzed, 62 had decisions on facility location, and of these 62, 47 measured the effects of decisions on facility location by the number of jobs that is created by this decision. Or, for example, 32 articles had decisions on transportation quantities, and half of them used the number of jobs to measure the effects of this kind of decision. We can also look at this in relative terms, and then it gets even clearer that the number of jobs is by far the most prevalent of the social indicators, and also the only consistently applied one. There are a few outliers here and there. For example, the decision on facility technology is in 46% of the cases measured by the days that are lost due to work damages with the respective facility technology. But all the other kinds of indicators and all the other combinations between decision in this kind of decision problem and indicator fall to the wayside. And of course, we want to make this a little bit better, maybe. We've seen that the number of jobs is the only consistently applied indicator. And also, what I couldn't show you due to time constraints is that when a study has an objective function with different terms that have different units, just as our exemplary objective function, then what most studies do is just to put a weight to each of these terms, and so that the overall unit of the overall objective function is just a social score maybe, but ultimately the information of the actual indicators is lost, and so we have a small set of consistently applied indicators and very basic methods of aggregation of different units or different indicators. And so here's how we want to go about this. Our case is a strategic network design problem of bioethanol production in the European Union, and it's currently under review in the Journal of Industrial Ecology. And in this article, we optimized this network in terms of economic and 21 different environmental objectives separately. And now we want to integrate the social dimension. And at this point, I wanted to show you the first results for that, and talk a little bit about our approach. But the results fell a little bit into the Corona gap. So all I have to show here is our approach, but we are very open for feedback on this, because we are not SLCA practitioners, but want to advance our discipline in terms of the social dimension. For the indicator selection, we first took the guidelines for social life cycle assessment of products and their methodological sheets, which present us with 190 indicators. Of these 190 indicators, 110 were only site-specific or too local for being applicable to our case. Then there are another 5 that could be applicable but are rather not affected by the decisions that we have right now. And when we exclude some more, we end up with a total of 53 indicators that could be applicable to our problem. However, of these 53 indicators, we at least currently identified only about 10 where the network's decision exert a distinctly positive or negative impact, so that I can say, if I open my facility in this region with this capacity, then it has this or that positive or negative social impact. The subcategories that these indicators cover are local employment, access to material resources, health and safety, fair salary of workers, contribution to economic development, and technology development. So the first objective functions could look like this. We could have an objective function that, as in all of the other papers, maximizes the number of jobs depending on the unemployment rate, but we could also have an objective function that favors locally based suppliers. We have 3 different objective functions for access to material resources. We could have one objective function for the health and safety of workers, which could depend on the decision variable of the quantity of production times the risk depending on the product, and so on. And I don't want to go into too much detail here because we are still in the progress of composing these objective functions, but I'm really thankful for some input. I had really hoped for a physical conference so that I could discuss after this presentation with some of you experts about this, but in this context of strategic network design, how would you go about this kind of problem? And I'm really looking forward to discuss this with some of you sometime. So thank you very much for your attention. Tack så mycket för din uppmärksamhet.